The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
So for number 5, the last bonus problem, this is another one that we're going to need to do by U substitution. So it might not be immediately obvious which one should be which, or what we should substitute here. But what I'd like to point out is that e to the 8x is exactly the square. Let me write down the problem first here. E to the 8x is the same thing as e to the 4x squared. So u being e to the 4x would actually make a lot of sense here, because then we'd be able to get rid of we could make this x or u squared on the bottom because it's that, and this will still cancel out in the top. You can see if you set u equal to e to the 8x, you would never get this to cancel out through u substitution. So we get du equals 4e to the 4x dx. If we rewrite our integral, so we're going to have u over u squared plus 4. But instead of dx, we're going to have du over 4. And instead of e to the 4x, I'll write that as u, just so we can see that these cancel out. We get a 1/4 out front here. And we're really just integrating u squared plus 4. So you should be able to tell right away this is an arctangent form. Because we have, well, essentially 1 over something squared plus a number. In this case, our number is not exactly 4, though, and that's what we need to fix. So what you can do, you can think about this like factoring a 4 out of the denominator. So if you took a 4 out here, what would you be left with? We'd be left with u squared over 4 plus 1. Now this 4 can really just come out of the integral and stack up with the other one and make 1/16. And now we'll have 1 over u squared over 4 plus 1. Remember that for an arctangent form you really actually have to have a plus 1 there. But to take this even one step further, u squared over 4 could be written as one term as u over 2 squared. U over 2 quantity squared, if you square that, you do get u squared over 4. But we want to do this in order to have it as our arctan. So if you don't see this right away, you might have to do another substitution here. But since we're just dividing by 2, we're just going to have to multiply our answer by 2 instead of doing that substitution, if you think about it that way. I'll just do the substitution here just in case. So we already did a substitution with u, so let's use a different variable. And let's just say u over 2 is equal to w. That's going to be our substitution. You can see here that if you do the derivative, or I guess I should have written that backwards. W equals u over 2. That's going to be our substitution. So this is just 1/2 du, and of course du then is just 2 dw. So we really have that. So in doing 2 substitutions, we're just going to have to plug back in twice. But what it boils down to is that this is an arctan. So we get 1 over 8 arctan of w plus c. You want to think, what was w? W was u over 2. If you recognize that you would have just had to multiply this by 2 and not done a whole second substitution, that's fine. I just wanted to show it out and show you that it does work that way. And then finally, instead of u, we should be putting e to the 4x. So we should have arctan of e to the 4x divided by 2 plus c, and that's our final answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.